one. Okay, so we're going to do the west of it. So we're going to the west of the state. See, now when we get it back on YouTube. It's not sticky. I got 31 minutes. You're probably gonna run out. But I enjoy a few videos. Ooh. This is interesting. You'll probably like this. Just one.
Hey everybody, today we're going to be seeing what happens when two black holes collide. So if for some reason you're not aware, we just recently got news that the very first picture of a black hole has been taken. But today I'm going to be showing you what it looks like if you were to actually drop one black hole inside of the other. Would it just swallow it up? What would happen at the boundaries? What would happen at the event horizons as the black holes come near each other? Now, in order for two black holes to collide together, what you need is two black holes traveling in opposite directions coming near each other. But because space is so big and black holes are so small compared to space, as those come near each other, most likely they're going to miss each other. There's almost 0% chance they're just going to hit each other head on. So what will most likely happen is that they'll miss each other. But as they come near each other, they're going to be affected by each other's gravity. So they're going to come near, and they're going to pass each other, but they're going to pull each other back, and then they're going to start spinning around each other like this. And then as they spin around, something interesting is going to happen. They'll kind of reach an equilibrium state, but they'll start to lose energy. And one way that they lose energy is through gravity. So as these two black holes are orbiting each other, they're going to orbit each other really fast. And as they're orbiting each other, they actually send out gravitational waves. Now, these are the same gravitational waves that were picked up by LIGO in 2016. We actually picked up these gravitational waves from two rotating black holes that were about to collide together. So as these black holes orbit around each other really fast, they're sending out gravitational waves, and those waves actually carry energy away from the black holes, so they lose angular momentum and they get closer and closer and closer together until their event horizons start to overlap. And then let's see what happens after that. Now, before we continue, I'd like to thank the sponsor of this video, Dashlink. So if you had to guess right now, how many passwords would you say that you have?
I forgot about that.
So for me right now, with all my social media accounts, bank accounts,
1 second, I got 31 minutes and 6 seconds. No!
To generate some very secure passwords like this. Now, if you want to try out Dashlink for free, remember to click the link in my description to get Dashlink Premium for free for 30 days.
I got
now,
31
let's go check
minutes
out the collision of black holes. Okay, so to show you what I mean, I have a black hole here, and I'm going to another black hole.
I got 31 minutes and
and
6 seconds.
So this black hole right here is going to be shot near it, and the gravity from this main black hole is going to pull it towards it, but it's not going to hit it, it's just going to pull it towards it and slingshot it the other way. 3, 2, 1. See it falling towards it, it's going to go behind it, and slingshot it behind it, and then fly off the other side.
What time you want to go to Mom's?
So it never actually got sucked into the
After I
main black hole.
record a few more videos.
But every once in a while, you'll
1
get
o'clock?
two black holes that happen to be in a binary
You
orbit.
can record them in the car too,
And the way that
and at Mom's
happen
house.
is if there are two stars that are orbiting each other, and one of the
Leaving at
stars
1.
undergoes a supernova and turns into a black hole, and then the other one undergoes supernova and turns into a black hole, so those two black holes stay orbiting each other. And it would look something like this. So I'll place one black hole right here, and then I'm going to put the other one in a binary orbit with it. So you can see how they both orbit each other. But they're not really falling into each other yet. So look how cool it looks for two black holes to be orbiting each other. You can see how the light lenses around the black hole. This is due to the bending of space-time itself. So you can see these two black holes come very close to overlapping their event horizon. you can see right away that a black hole looks like it has a volume, but it doesn't really have a volume. It's called a singularity, meaning that all the mass of the entire black hole is contained in a single point. It's smaller than an atom. It's even smaller than a Planck length. That means that every single thing that has ever gone into that black hole is contained in a singular point in the center with no volume whatsoever. But the only reason it looks like it has a volume is because the effect of the gravity stops light from escaping at a certain distance. And so around that certain distance, you can't see light anymore. So it looks like there's kind of this spherical volume around it, when in reality, there's no volume whatsoever to a black hole. It's just one single point. Now, as these black holes orbit around each other, I'm locked in on the center one, so both of them are actually moving here. But as these black holes orbit around each other, eventually they're going to get closer and closer together as they lose energy through gravitational waves. So in honor of the black hole that we just took a picture of, M87, which has a mass of around 2.4 billion suns, I'm going to be colliding two M87 black holes together. Now this M87 black hole is huge, and by huge I mean it's massive. And because it's massive, the event horizon around it, the dark area around it, is huge. For example, this is our sun in our own solar system, and let me zoom out a little bit. You can see the orbit of Mercury here, Venus, Earth, Mars, keep zooming out, Jupiter with all its moons around it, Saturn, Uranus, Neptune, and now look at this black hole. So you can see how the diameter of the event horizon is as big as our entire solar system. So this black hole is huge. Okay, so I have my two M87 sized black holes here. So I'm going to be placing one M87 black hole and then place the other one around 1,000 AUs away. Okay, here we go. 3, 2, 1. And boom. So what happened here? Well, what happened is both black holes combined together into one bigger black hole. And what's cool is if you just keep adding black holes to other black holes, they just keep swallowing more and more black holes and becoming bigger and bigger and bigger. Because as they get more mass, their event horizon gets larger. And so it just keeps growing and growing and growing. Basically, it's kind of like adding bubbles together. When bubbles come near each other, they kind of suck each other in and become a bigger bubble altogether. And so you can see as I just keep adding black holes to the original black hole, it just grows bigger and bigger and bigger and bigger. Until eventually, you can get a black hole that has the mass of an entire galaxy. In fact, you can get a black hole that has a mass of thousands or millions of times more than a galaxy. Okay, now how about if we add a super giant black hole next to a galaxy like our Milky Way? So you can see that a galaxy contains pockets of dark matter. There's a supermassive black hole in the center that these stars are orbiting around. But what if we put a black hole just near it? So this black hole now has the mass of 1,700 Milky Ways. And I'm not talking about the candy bar. So let's see what happens now. Let's increase the time scale here. Whoa, it's all coming towards it. Whoa. It sucked in all the stars and now they're orbiting around it, eating them all up. So you can see the supermassive black hole from the other galaxies are now orbiting this huge black hole here, the size of a galaxy. Okay, now let's do something that's never been done before. Let's take one of these dark matter masses in the galaxy and let's add to its mass. And so basically I'm going to keep adding to its mass until the dark matter itself becomes a black hole. So you can see I increase the mass of it.
I can make real
It
videos
collapses
now.
in on itself and becomes a black hole.
This will give me 1 diamond and 6 seconds.
And now it's a supermassive dark matter black hole. And you can see now it sucks in the entire galaxy. It's now a dark matter black hole. Hey everyone, thanks for watching another episode of the Action Lab. I hope you liked it. If you did, hit the subscribe